According to the National Electrical Code, all electrical connections must be accessible for inspection and maintenance. This includes splices and thermostat wires. Even though a splice might be in a garage with a fire-rated ceiling, it is still possible that it could fail over time. If the splice fails, it could create an electrical hazard and cause a fire. To prevent this, the splice must be accessible so that it can be inspected and repaired if necessary. There are a few ways to make the splice accessible. One option is to install a junction box near the splice. The junction box provides a readily accessible enclosure for the splice, allowing for future inspection and maintenance without disturbing the fire-rated ceiling. This is typically the preferred method as it offers the easiest access. When selecting a junction box, ensure that it is appropriately sized for the number and size of conductors being spliced, and that it is rated for the environment in which it will be installed. This includes considering factors such as temperature and humidity. The junction box should be securely mounted to a structural element of the building to prevent it from being dislodged or damaged. All wiring entering the junction box must be properly secured using appropriate cable clamps or connectors to prevent strain on the connections. Another option is to use a waterproof splice kit that can be buried in the insulation. While this method allows for the splice to be concealed, it's crucial to select a splice kit specifically designed for direct burial and suitable for the type of wire being used. The splice kit must provide a watertight seal to prevent moisture from entering the connection, which could lead to corrosion and eventual failure. Before burying the splice kit, it is essential to thoroughly inspect the connection to ensure that it is properly made and that there are no exposed conductors. Additionally, consider documenting the location of the buried splice for future reference. If you are not comfortable making the splice yourself, you should hire a qualified electrician to do it for you. A qualified electrician has the knowledge, skills, and experience to safely and correctly make the splice in accordance with all applicable codes and regulations. They will also be able to assess the specific conditions of the installation and recommend the most appropriate method for making the splice accessible. This could include factors such as the type of wiring, the location of the splice, and the presence of any environmental hazards. By hiring a qualified electrician, you can ensure that the splice is made safely and correctly, and that it will provide years of reliable service. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is not law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is designed to protect people and property from electrical hazards. The NEC is divided into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC also includes tables and figures that provide additional information and guidance. The NEC is a complex document, and it is important to understand the requirements that apply to your specific situation. If you are not familiar with the NEC, you should consult with a qualified electrician. Accessibility is a key concept in the NEC. It refers to the ability to access electrical equipment and connections for inspection, maintenance, and repair. The NEC requires that all electrical equipment and connections be accessible unless specifically permitted otherwise. There are several reasons why accessibility is important. Firstly, it allows for a regular inspection of electrical equipment and connections. This can help to identify potential problems before they become serious hazards. Secondly, it allows for maintenance and repair of electrical equipment and connections. This can help to extend the life of the equipment and prevent costly breakdowns. Thirdly, it allows for easy access in the event of an emergency. This can be critical in situations such as a fire or electrical shock. The NEC specifies different levels of accessibility for different types of electrical equipment and connections. Some equipment and connections must be readily accessible, meaning that they can be accessed without the use of tools or ladders. Other equipment and connections may be accessible by the use of tools or ladders, but they must not be obstructed or blocked. Still, other equipment and connections may be permitted to be inaccessible, but only under specific conditions. The requirements for accessibility depend on the type of equipment and connection, the location of the equipment and connection, and the potential hazards associated with the equipment and connection. In general, equipment and connections that are more likely to require inspection, maintenance, or repair must be more accessible. Equipment and connections that are located in hazardous locations must also be more accessible. When designing an electrical installation, it is important to consider the requirements for accessibility. This includes choosing the right location for equipment and connections and ensuring that there is adequate space for access. It also includes providing appropriate access methods such as doors, hatches, and ladders. Failure to comply with the accessibility requirements of the NEC can result in fines, penalties, and even the shutdown of your electrical system. It can also create safety hazards that could lead to injury or death. Therefore, it is essential to understand and comply with the accessibility requirements of the NEC. When splicing thermostat wire, it is important to use the correct type of connectors. The connectors should be rated for the voltage and current of the thermostat wire, and they should be suitable for the environment in which they will be installed. There are several different types of connectors that can be used for splicing thermostat wire. One common type is a wire nut. Wire nuts are small, plastic connectors that are used to twist two or more wires together. They are easy to use and relatively inexpensive. Another type of connector is a crimp connector. Crimp connectors are metal connectors that are crimped onto the wires using a special tool. They provide a more secure connection than wire nuts, but they are more difficult to install. A third type of connector is a push-in connector. Push-in connectors are plastic connectors that allow you to simply push the wires into the connector without the need for twisting or crimping. They are very easy to use and provide a secure connection. When choosing connectors for splicing thermostat wire, it is important to consider the following factors. Firstly, the voltage and current rating of the connectors. Secondly, the type of wire being spliced. Thirdly, the environment in which the splice will be installed. Fourthly, the ease of installation. And fifthly, the cost. In addition to using the correct type of connectors, it is also important to make the splice correctly. The wires should be stripped of insulation and twisted together tightly. The connector should be properly installed and tightened. The splice should be insulated to prevent short circuits. If you are not comfortable making the splice yourself, you should hire a qualified electrician to do it for you. Improperly made splices can create electrical hazards and cause fires. Therefore, it is important to take the time to make the splice correctly or to hire a qualified electrician to do it for you. When running thermostat wire, it is important to follow the NEC guidelines for wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. It also specifies the requirements for installing wiring, such as the minimum size of conductors, the spacing between conductors, and the support of conductors. Thermostat wires typically run in one of two ways: firstly, exposed, or secondly, concealed. Exposed thermostat wire is run on the surface of walls or ceilings. It is typically supported by staples or cable ties. Concealed thermostat wire is run inside walls or ceilings. It is typically run in conduit or cable. When running thermostat wire, it is important to avoid running it near heat sources, such as furnaces or water heaters. Heat can damage the thermostat wire and cause it to malfunction. It is also important to avoid running thermostat wire near sources of electromagnetic interference, such as motors or transformers. Electromagnetic interference can interfere with the operation of the thermostat. When running thermostat wire in a garage, it is important to protect it from physical damage. Garages are often used for storage, and thermostat wire can be easily damaged by tools or equipment. To protect thermostat wire in a garage, it is typically run in conduit or cable. It can also be protected by installing it behind a wall or ceiling. When running thermostat wire, it is important to follow the NEC guidelines for grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to protect people from electrical shock. The NEC requires that all electrical equipment be grounded unless specifically permitted otherwise. Thermostat wire is typically grounded by connecting it to the grounding conductor in the electrical panel. The grounding conductor is a bare or green insulated wire that runs from the electrical panel to the earth. It is important to ensure that the grounding conductor is properly connected to the thermostat wire and to the electrical panel. Improper grounding can create electrical hazards and cause electrical shock. Therefore, it is important to follow the NEC guidelines for grounding when running thermostat wire. When installing a fire-rated ceiling in a garage, it is important to ensure that all electrical wiring is properly installed and protected. Fire-rated ceilings are designed to prevent the spread of fire. However, they can also trap heat and smoke, which can make it difficult to escape in the event of a fire. Therefore, it is important to ensure that all electrical wiring is properly installed and protected to prevent electrical fires. Before installing a fire-rated ceiling, it is important to inspect all electrical wiring to ensure that it is in good condition. Any damaged or worn wiring should be replaced. All electrical connections should be tight and secure. All electrical boxes should be properly grounded. If you are not comfortable inspecting electrical wiring yourself, you should hire a qualified electrician to do it for you. Once the electrical wiring has been inspected, it is important to protect it from damage during the installation of the fire-rated ceiling. This can be done by running the wiring in conduit or cable. It could also be done by installing the wiring behind a wall or ceiling. When installing the fire-rated ceiling, it is important to avoid damaging the electrical wiring. Do not nail or screw into the wiring. Do not cut or tear the wiring. If you accidentally damage the wiring, you should repair it immediately. After the fire-rated ceiling has been installed, it is important to test the electrical system to ensure that it is working properly. Turn on all of the lights and appliances in the garage. Check for any signs of electrical problems such as flickering lights, sparking outlets, or tripping circuit breakers. If you notice any electrical problems, you should call a qualified electrician to inspect the system. By following these steps, you can ensure that all electrical wiring in your garage is properly installed and protected, and that your fire-rated ceiling will provide the protection that it is designed to provide. Always consult with a qualified electrician for any electrical work. Electrical work can be dangerous, and it is important to have the work done by someone who is qualified and experienced. A qualified electrician will be able to ensure that the work is done safely and correctly, and that it complies with all applicable codes and regulations.